Hi students, today we are learning the topic is methods to reduce quadratic form to canonical form. So in the previous lecture already one of the method we will discussing that is the first method, orthogonal transformation. In that method, how to converted given quadratic form to canonical form. So that is a first method is completed. See the second method. The second method is diagonalization transformation, or this is also another form congruent transformation. So how to convert the given quadratic form to canonical form? In this method, diagonalization transformation. Okay, see the first of all procedure here, definition. So that is congruent transformation consists of a pair of elementary transformations, that is one row and a similar column such that free and forced matrices are transpose of each other. That is equal to here the given diagonalization transformation must be consistent of similar transformation, and one row and same one column, both using a transformation, the same using same operation on row and column, that is a pre matrices and post matrices. Row operation emo on pre matrices, column operation on post matrices. So that is the consistence of a pair of elementary transformation, similar transformation. So that is, if Q is equal to X transpose AX is a quadratic form, then there exists a non-singular transformation, that is a linear transformation assumption. X is equal to py. Already I told in the previous lecture, X is equal to py. This is a transformation, linear transformation, and P is a non-singular matrix which transform the given quadratic form X transpose AX to. So this is a canonical form. Already I told canonical definition, only the sum of the squares of same variables. That is eliminating the products x, y, y, z, zx is eliminated. Then the new form is y transpose d into y. D is a diagonal matrix. As y transpose d into y is a form is called canonical form. This is the only diagonal element choosing the sum of the squares of same variable, that is called canonical form. But here coefficients are b1, b2 up to so on. Br is only any numbers, there is only constant, that is not eigenvalues. And the first method lo eigenvalues of the coefficient matrix, but here not eigenvalue, that is any constants. Okay na, this form is called canonical form. Okay, in this method we assumption given coefficient matrix A is equal, we write I into A into I and A. So this is a procedure here. We write A is equal to I into AI. So this AI is a free multiplication matrix, this I is post multiplication matrix. Okay na, so this equation reduced to D is equal to P transpose AP, and D is equal to, and the given matrix is reducible to this diagonal matrix, and automatically this matrix is reduced to some other matrix P transpose, and A is a fixed next to I forced matrix is converted to the P matrix. This is a P transpose AP. P transpose AP is equal to diagonal matrix. So by using row and similar transformation, this method is called diagonalization transformation. Okay, understood? Yeah, see the one of the example here. Yeah, reduce the following quadratic form to canonical form by diagonalization transformation. Also find the rank, index, signature and nature, and also linear transformation of the quadratic form. So a given quadratic form, this is a given quadratic form. Okay now, see the solution. So given Q is equal to, which is a quadratic form, first of all finding the matrix notation, and X transpose A into X. X transpose is given number of unknowns 3. So that is equal to X transpose AX. So X transpose ante matrix of unknowns x1, x2, x3, and coefficient matrix. So here elements, coefficients of squares of same element, that is the diagonal elements 1, 2, 3. This is the diagonal elements, that is 1, 2, 3. Next one x1, x2 coefficient 2 kada. 2 is half, that is 1, 1. Next to x1, x3. x1, x3 coefficient minus 2, that is half of minus 1, here minus 1. Next x2, x3 coefficient 2, that is half of 1, 1. This is the coefficient A, and X is a column matrix. Okay, that is equal, where A is equal to the matrix 1, 1, minus 1, 1, 2, 1, minus 1, 1, 3. Okay, na? So in this method now we write I is equal to, sorry, A is equal to I into A into I kada. Okay, na? So continuation. So let A is equal to, A is a 3 by 3 matrix, so I is also unit matrix, 3 by 3 unit matrix. A is equal to I3, A, I3. So that is equal to, A is a given matrix. So this is a given matrix, and so I3 is a unit matrix 3 by 3, and A is a fixed. Next also this forced matrix I. Okay, now our aim is, this is converted to the diagonal matrix using row and column similar operations. If using the row operations, same operations applying on pre matrices. If using the column operation, the same column operation applying on post matrices, this matrix. Okay, na? Our aim is first of all these two element zeros, and a row echelon form and column echelon convert చేసుకోవాలి మనం. So first using row echelon form, this element 0, this element 0. Okay, na? Using R1, that is equal to R2 minus R1, next R3 plus R1. So that is equal to 1, 1 minus 1, 0, 1, 2, 0, 2, 2. Okay, now the same operation on this matrix only, on this matrix, same operation. R2, 1, 0, 0, first row same. R2 minus R1, 0 minus 1, minus 1. Next to 1 minus 0, 1. 0 minus 0, 0. Next to R3 plus R1, 0 plus 1, 1. 0 plus 0, 0. 1 plus 0, 1. So remaining same and no change this matrix. Only row operation on applying on free matrix. Okay, na? Next similarly column operation, same operating, that is row operations R2 minus R1, R3 plus R1. So similarly column operation C3 minus C2 minus C1 and C3 plus C1, same operation use cheyali. That is equal to C2 minus C1, C3 plus C1. So that is equal to, ఇక్కడ ఏమొస్తుంది మనకి, this element zeros, అవునా, this element 0 and this element 0. That is equal to 1, 0, 0 same, 1 minus 1, 0, 1 minus 0, 1, 2 minus 0, 2. Next to C3 plus C1, minus 1 plus 1, 0, 2 plus 0, 2, 2 plus 0, 2. So same column operation on applying on this first matrices. This is the same, and this is a two matrices, no change. Okay, na? 1, 0, 0, minus 1, 1, 0, 1, 0, 1, same. A. Ikkada C1 same. 1, 0, 0. Avuna? C2 minus C1 kada. 0 minus 1, minus 1. 1 minus 0, 1. 0 minus 0, 0. Next to C3 plus C1, 0 plus 1, 1, 0 plus 0, 0, 1 plus 0, 0. Okay, na? This is a continuation now. So next our aim is this element 0 using row operation. Next one continuation, same row operation on column operation. Next this element zeros. Okay, first of all this element 0 using R2. So that is equal to R3 minus 2R2. that is equal to 1 0 0 0 1 2 0 0 minus 2. This element 0 అయిపోయింది. The same row operation on free matrix. This matrix apply 1 0 0 minus 1 1 0 3 minus 2 1. So this is a similarly same, no change. Okay na. Next continuation similar transformation on column, that is C3 minus 2 C2. C3 minus C2. Same operation you shall, no change. Okay na. That is this element 0. So first column 1 0 0 same. Next second column same 0 1 0. Next C3 minus 2 C2 0 minus 0 0. 2 minus 2 0 minus 2 0 minus 2. Okay na. The same column operation on this matrix. This matrix no change. Okay na. So that is equal to first 1 0 0 minus 1 1 0 3 minus 2 1 A. So that is equal to here C1 same, C2 same. C3 is C3 minus 2 C2 కదా అంటే 1 minus plus 2 plus 3. Okay na. 0 minus 2 minus 2 1 minus 0 1. So this is the matrix. So observing here, this matrix is diagonal matrix together. All elements are 0 except diagonal elements. This is a diagonal matrix D. Okay. So that is comparing with D is equal to P transpose AP. So then this is a P transpose and A, this is a P matrix. So that is equal to D is equal to P. So one more thing observing here, P and P transpose both are equal అండి, but only interchanging. There is a transpose ఇక్కడ చూడండి. This is a P transpose, this is a P matrix. చూడండి P matrix లో ఫస్ట్ రో 1 minus 1 3, P transpose లో 1 minus 1 3 ఫస్ట్ కాలం చూడండి. ఫస్ట్ రో ఫస్ట్ కాలం సేమ్. నెక్స్ట్ సెకండ్ రో 0 1 minus 2, this second column 0 1 minus 2. Next third row 0 0 1, that is third column in P transpose 0 0 1. So both are same only by mutually transpose both. Okay now this is a D matrix, this is a P matrix. Okay na. So already converted diagonal matrix. A is converted to diagonal matrix. So next finding linear transformation. First finding, so linear transformation is x is equal to py kada, and x is the given unknowns of matrix, y is the matrix of new variables. So that is equal P is equal to here this matrix P, model matrix P. Okay, that is a non-singular matrix which is transform the given quadratic form to canonical form. Okay, that is equal to x is equal to given matrix x1 x2 x3. So P is a P matrix, non-singular matrix, this matrix. Okay, y is a new variable matrix y1 y2 y3. So that is equal equating, this is x1 is equal to first row first column multiplication with the adding, that is equal to x1 is equal to y1 minus y2 plus 3y3. Next x2 element, x2 is equal to second row into first column, that is equal to x2 is equal to y1 coefficient 0 y2 minus 3y2. Okay, next x3 is equal to third row first column 0 into y1 plus 0 into y2 plus y3. So this is a x3. So this is a linear transformation. Okay now, which is also using now finding canonical form. So the canonical form is x transpose A x కదా, and x place లో py substitute, that is py all transpose into A py, that is equal to y transpose P transpose AP into y, that is equal to y transpose P transpose AP is equal to diagonal matrix D into y. So that is equal to y transpose means this is the y1 y2 y3 is a new variable. So this is a diagonal matrix already finding. Okay na, D is equal to 1 0 0 1 0 1 0 0 0 minus 2. This is a y, y1 y2 y3 kada. So now multiplication is the only diagonal elements kada. The diagonal elements is the coefficients of only same squares of variable. And the first, this is the first one coefficient y1 square coefficient, this is a y2 square coefficient, this is a y3 coefficient, that is equal to y1 square plus y2 square minus 2y3 square. This is a canonical form. So from this canonical form we have to finding rank, index, signature and nature. Okay, so that is equal to rank, number of non-zero terms in the canonical form. So 3, number of non-zeros 3 kada, 1 2 3, 3 non-zero terms, that is the rank is or 3. Next, index. Index means the number of non-zero positive terms. Number of positive terms here only 2 kada. So index is 2. Index P is equal number of positive terms in the canonical form is 2. Next, signature. Signature means the difference between positive and negative terms. So positive terms is 2, negative terms 1. 2 minus 1 is equal to 1. That is equal to 2 minus 1 is equal to 1. This is a signature. Next, nature. Nature means that in the canonical form the terms are as well as positive and negative kada. So that is equal to indefinite. Nature is indefinite. So that is equal to indefinite. Okay, now this is the method of diagonalization transformation, which is convert to the canonical form. Okay, now. So see the next second example. Same procedure, reduce the following quadratic form to canonical form by diagonalization. Also find the rank, index, signature and nature, and also linear transformation of the quadratic form. Okay, so this is the second quadratic form, the same procedure. So given Q is equal to given quadratic form. So first of all finding the matrix notation. So X transpose AX. So X is a matrix of unknowns 3, x1, x2, x3. Next coefficient matrix A, x1 square, x2 square, x3 square coefficients here 1, 4, 1. That is the diagonal elements 1, 4, 1. Okay, now next x1, x2 coefficient minus 4 and half of, that is minus 2, minus 2. Next x1, x3 coefficient 2, that is 1, 1 off. Next to x2, x3 coefficient minus 4, that is equal to half of minus 2, minus 2. This is the x. So therefore the coefficient matrix A is equal to 1, minus 2, 1, minus 2, 4, minus 2, 1, minus 2, 1. Okay, now. So now procedure we write matrix A is can be write I, A, I. Okay, next continuation. So A is equal to I3, A, I3. That is equal to given matrix A, I3. 3 by 3 matrix A into I3. Okay, na? Next our aim is, this is converted the row echelon form and column echelon form. So using row and column similar operations, first of all these two element zeros using R1. That is R2 plus 2R1, R3 minus R1. That is equal to 1 minus 2, 1, 0, 0, 0. Next 0, 0, 0. The same row operations on free matrix, this one. That is 1, 0, 0, 2, 1, 0, minus 1, 0, 1. So this two matrices same, no change. A, this matrix. Next to same column operation using, that is C2 plus 2C1, C3 minus C1. So same row, similar column operations. C2 plus 2C1, C3 minus C1. That is equal to here. And this element 0, this element 0 anamata. 1, 0, 0, 0. Next 0, 0, 0. Next 0, 0, 0. Next same column operation on this matrix, but no on this matrix. Okay, na? This is same untadi. 1, 0, 0, 2, 1, 0, minus 1, 0, 1. A is same. Next here, first column same, 1, 0, 0. Next to C2 plus 2C1. 0 plus 2, 2, 1 plus 0, 1, 0 plus 0, 0. Next to C3 minus C1. 0 minus 1, minus 1. 0 plus 0, 1 minus 0, 1. Okay, na? So next one already is completed. Chudandi. All are 0 except diagonal elements. So diagonal elements also same. That is equal to here. This is a diagonal matrix D is equal to this is the matrix P transpose A. This is a P. No? That is equal, let canonical form is Q is equal to Y transpose dy, direct write down. X place of py replaces the direct, we getting the canonical form is Q is equal to Y transpose D into Y. Y transpose is the matrix of new variable, that is equal to y1, y2, y3. This is a diagonal matrix. Why the diagonal matrix? So this is a diagonal matrix, and 1 0 0 0 0 0 0 0 0 into y matrix, new variable. So that is equal to only diagonal elements coefficients together. Squaring of the same variables. The first one 1 into y1 square plus 0 into y2 square plus 0 into y3 square. So this is the canonical form. So in the canonical form, finding rank. Rank is equal to number of non-zero terms. Number of non-zero terms is only 1 agada. Remaining 2 zeros. That is 1. Rank is 1. Next index. Index is number of positive terms. Non-zero positive terms is only 1. So index is also 1. Next signature. Signature is difference between positive and negative terms. Positive terms only 1. Negative sum zeros. 1 minus 0 1. Next nature is terms are positive and 0 terms, and that is equal to only positive semi-definite. That is the nature is positive semi-definite. Okay, now this is the canonical form and rank, index, signature and nature. So next finding linear transformation. What is the linear transformation? X into py. That is equal to x into py is equal to the linear transformation. X is equal to given matrix of unknowns. P is a P matrix already finding. So this is the y is a new variable of matrix. That is equal x1 is equal to first row into column matrix. X1 is equal to y1 plus 2y2 minus y3. Next x2 is equal to second row. That is y2. X2 is equal to y2. X3 is equal to here only 1 y3. So this is the linear transformation. Okay, this is the method to diagonalization transformation. The given quadratic form is converted to canonical form. Okay. Yeah, thank you. For more videos, please do subscribe my channel and like, share it. Thank you.